Welcome to the Deep Dive, your shortcut to really understanding the tech that shapes our world. Today, we're getting into the weeds with retrieval augmented generation.
Yeah.
RA. This is the tech that was basically supposed to be the fact checker for large language models, stopping them from just making things up.
Exactly. RA is fundamentally about connecting two worlds. You've got the LLM's brain, its internal knowledge from all that training data. We call that parametric knowledge. And then RAG adds the outside world-specific documents, websites, your notes. That's the external data. It's trying to marry those two.
Right. The educated brain meets the latest news report. But the sources we looked at for this deep dive show it's not quite a happy marriage. It seems like our age is causing its own kind of internal conflict for the AI. So our mission today is to really unpack what happens when that external knowledge isn't perfect, when it actually muddies the waters. We're focusing on two big problems, imperfect retrieval and these knowledge conflicts that pop up.
Yeah, it's a bit ironic, isn't it? We built Argot to fix the LLM's unreliability, but now the Argot process itself has these failure points. We're going to look at a really interesting academic approach first, called Astute RAG, which tries to solve this with a structured framework. And then we'll pivot and look at a big commercial player, Google's NotebookLM, to see how these exact same challenges play out in a tool people are actually using every day.
Okay, so let's set up that central tension first. We need RAG, right? Because otherwise, the LLM is just riffing off its training data, which can be outdated or just plain wrong, hallucinations, basically. But the kicker seems to be that the retrieval step, the act of finding the relevant external fact, is often where things go wrong. And it's not just a small glitch. The sources say it's pretty systemic.
It really is. It's the classic garbage in, garbage out problem, but maybe even more insidious here. Because imperfect retrieval means the system isn't just finding nothing, it's finding the wrong things. Irrelevant stuff, misleading information, maybe even deliberately malicious content if you're searching the open web. And that bad input poisons the well for the LLM.
Exactly. You could have the smartest LLM ever created, but if the RAG system hands it faulty evidence, the LLM is likely to generate a response based on that bad evidence. And worse, it might present it confidently, with citations even, because it thinks it's grounded.
That's worrying. And you mentioned this isn't just a theoretical problem for small models. It happens even with top-tier search technology.
Yeah, the research we looked at confirmed this using analyses on standard, complex question-answering data sets, things like NQ, Trivia QA sets, designed to really push knowledge retrieval. They used state-of-the-art search components, the kind you'd find in real-world ARGI systems, often querying the web.
And the results were not great.
That's sobering. They measured retrieval precision, basically. What percentage of the snippets the RAG system retrieves actually contain the correct answer to the question asked? And the numbers were consistently low. Across these standard data sets, roughly 70% of the retrieved passages did not directly contain the true answer. Wow. 70%. So just to make that concrete for someone using this, I ask a question. RAG pulls maybe 10 snippets of text it thinks are relevant.
And based on this data, 7 of those 10 are likely to be useless or worse, misleading. They don't actually hold the key to the answer.
That's a huge amount of noise for the LLM to deal with right at the start.
It is. It means almost every RAG process begins with this significant information deficit, or rather an information overload of the wrong kind. The search part, whether it's keyword or vector search or hybrid, it's just not perfectly aligning with the nuances of the question most of the time.
So there's this semantic gap, what the user means versus what the search algorithm finds.
Precisely. And that leads us directly into the next big problem this noise creates. The knowledge conflict.
Okay, define that for us. What exactly is a knowledge conflict in this context?
It's when the information retrieved from the external source, that document you uploaded, or that web page RAG found directly contradicts what the LLM already knows from its internal parametric training data.
So the fresh data clashes with the old education.
You got it. The external snippet says X, but the LLM's internal knowledge base strongly suggests Y.
And how often does this happen? Is it a rare edge case or something more fundamental?
The data suggests it's pretty common. The analysis, using advanced models like Claude 3.5 Sonnet to evaluate the outputs, found that almost 20%, 19.2% to be exact, of the test cases showed these direct knowledge conflicts.
Nearly 1 in 5 times.
Yep. Almost 1/5 of the time, the external RAG results were actively fighting with the LLM's internal memory.
Okay, that really hits the core promise of RAG, doesn't it? We use RAG for trustworthiness to ground the AI. But if it's constantly creating these internal arguments...
Yeah,
Well, how can you trust the final output?
That's the danger. It introduces a new kind of uncertainty. And you hit on something important earlier. Does it get worse with better LLMs?
Yeah, my thinking was a more advanced LLM has more internal knowledge, so maybe it has more potential points of disagreement with external data.
And the data strongly supports that intuition. There's a tight correlation. The researchers found that for the most advanced LLMs, the rate of these knowledge conflicts actually peaks when the retrieval precision is very low.
Okay, so when the ARI system is doing its worst job, say, only 10% of retrieved snippets are actually relevant.
That's when the advanced LM is most likely to say, hang on, this external stuff looks wrong based on everything I know. The conflict rate spikes because the LLM has a stronger internal opinion to clash with the poor quality external input.
So this leads to a critical question. If there's a conflict, who do you trust? The LM's vast memory or the freshly retrieved, possibly noisy external document?
This is probably the most fascinating finding in the source material on this conflict issue. You might assume one is inherently better, right?
Maybe the external source because it's supposed to be more current or specific,
Yeah.
or maybe the LLM because it has broader context.
Well, the data shows it's incredibly close to a 50-50 split. When they looked at cases where there was a conflict and one source was demonstrably right and the other wrong, the LLM's internal knowledge was correct about 47.4% of the time,
Okay.
and the external retrieved knowledge was correct 52.6% of the time.
Wow, that is incredibly balanced. It's almost a coin toss.
It really is, and the implication is huge. You absolutely cannot just default to trusting one over the other.
Right. You can't just say, always trust the RJ results because they're wrong almost half the time in conflict scenarios.
Yes.
And you can't say, always trust the LLM's memory
Yeah.
because it's wrong almost half the time too.
Precisely. So simply turning off AG when retrieval seems bad or blindly prioritizing the external documents, those strategies are guaranteed to lead to errors pretty often.
So the ideal system needs some kind of arbiter,
Yeah.
something that can intelligently weigh both sources.
Exactly. It needs a mechanism for mutual correction. It needs to use the LLM's internal knowledge to spot and maybe fix the errors in the retrieved junk, that 70% noise we talked about.
Yeah.
And conversely, it needs to use the reliable external information to correct the LLM when its internal knowledge is wrong or outdated.
But just throwing both sets of information at the LLM and hoping for the best doesn't work.
Apparently not always. Other research mentioned in the sources suggests that when faced with conflicting info, LLMs sometimes latch onto unreliable shortcuts, like which piece of text sounds more confident or which came first, rather than doing deep reasoning about the actual evidence. They need structure.
Okay, this is the perfect setup for the next part of our discussion, because the academic world seems to have tackled this exact need for structure. Let's talk about Astute RAG.
Right. Astute RAG comes out of research from places like Google Cloud AI and USC. And its entire goal is to tackle these problems head-on. It aims to reduce the harm from imperfect retrieval, explicitly resolve these knowledge conflicts, and make the whole RAG process more resilient. Importantly, it wants to do this without losing the benefit of grounding when the retrieval actually is good.
And critically, it's described as training-free. What does that mean in practice?
It means you don't have to fine-tune the base LLM. You can take a powerful off-the-shelf model like Claude or Gemini or Mistral, these black box models, and apply this astute RAG framework kind of like a wrapper around it. It's about structuring the process, not changing the core model.
Okay, so it's like adding a smart layer of management around the LLM's interaction with the data. It is a three-step framework. Let's walk through that. Step one is adaptive generation of internal knowledge.
Yeah, so before even looking at the potentially messy external documents retrieved by RAG, the LLM is first prompted to generate its own answer or relevant passages based purely on its internal parametric knowledge. Let's call this I for internal.
It's best guess from memory first.
Right, but it's not just a simple brain dump. This generation is guided by what the researchers call constitutional principles. These are instructions baked into the PS prompt.
Constitutional principles, like rules it has to follow.
Exactly. Think of them as meta-instructions forcing the LLM to self-critique its own output. The principles demand that the generated internal passages must be accurate, relevant to the query, logically sound, and very importantly, free from hallucinations.
So it's trying to get the cleanest possible version of the LLM's internal knowledge before confusing it with external stuff.
That's the idea. And the adaptive part is also key here. The LLM doesn't just generate a fixed number of internal passages, it decides how many to generate, up to a set maximum.
Hmm.
If it generates one or two passages and then determines it doesn't have any more high confidence, reliable information internally, it just stops.
Ah, so it prevents the LLM from just rambling on and potentially introducing its own internal noise or speculation, quality control on the internal side.
Exactly. It avoids generating low confidence fluff just to meet a quota.
Okay, so now we have E, the external passage is retrieved by the standard RAG
Mm.
process, potentially noisy, and this carefully generated, constitutionally guided internal knowledge. Now, step 2, iterative sourceware knowledge consolidation. This sounds like where the magic happens.
This really is the core innovation of Astute RAG. First, it bundles all the passages together, the external E and the internal I, E do dialios E O plus I. But crucially, it labels each passage with its origin. The system knows this piece of text came from external retrieval, and this piece came from the LLM's internal memory. This source awareness is fundamental.
Okay, so the LLM isn't just seeing a pile of text. It knows the pedigree of each piece. What does it do with this labeled information?
It then uses another carefully crafted prompt, the CCON prompt, to guide the LLM through an iterative process of cleaning, organizing, and reasoning about this mixed set of passages. The prompt explicitly asks the LLM to do three things. 1, identify information that's consistent across different passages, both internal and external, and cluster those together. Find the consensus. 2, detect conflicting information. If some passages say X and others say Y, it needs to separate these into distinct conflicting groups. It doesn't immediately resolve the conflict, but it isolates it. And 3, filter out any remaining irrelevant information, stuff that might be related by keywords but doesn't actually help answer the specific question.
That third point, filtering irrelevant info. If the initial outrage search already let irrelevant stuff through, why would the LLM be better at catching it now?
That's a fair question. The initial RAG retrieval failure is often based on, say, vector similarity. Maybe the query was about apple stock and it retrieved something about apple pie recipes because the word apple is prominent. The LLM's filtering in this step is more sophisticated. It's looking at the passage in the full context of the query, its own internal knowledge, and the other retrieved passages. It can make a more nuanced judgment call. Okay, this apple pie stuff, while containing apple, is semantically unrelated to the financial query and my internal knowledge about Apple Inc. So it filters it out based on relevance to the task, not just keyword similarity.
I see. It's a deeper level of semantic filtering, enabled by having both internal and external context, plus the source awareness. So let's take our earlier conflict example. Internal knowledge I, it says Einstein born 1879. External RAG retrieval E finds one document saying Einstein born 1897. How does this consolidation step handle that? Does it pick one?
In step 2, it doesn't pick one yet. It identifies the conflict and creates two distinct clusters or groups. Group A, passages supporting 1879, source, internal. Group B, passage supporting 1897, source, external. The judgment call comes in the final step.
Okay, step 3, answer finalization. This is where the verdict comes down.
Right. Based on the consolidated and potentially conflicting groups identified in step 2, the LLM is prompted to propose candidate answers from each coherent group. Then, critically, it compares the reliability of these candidates, and it uses several factors for this comparison, leveraging that source awareness.
What factors does it consider?
It looks at, first, the explicit source was the supporting information internal or external. Second, cross-source confirmation. Did multiple different sources, either multiple external documents or internal plus external, agree on this point? Third, frequency, how many passages overall supported this candidate answer. And fourth, thoroughness, how detailed and comprehensive was the information supporting each candidate.
So in the Einstein example, if the internal memory said 1879 and maybe two external documents also said 1879, while only one noisy external document said 1897.
Then the system, weighing these factors, would see stronger cross-source confirmation, higher frequency, and potentially more thoroughness for the 1879 date. It would therefore select 1879 as the final, more reliable answer, effectively using the consensus and source information to resolve the conflict.
That makes a lot of sense. It's turning the conflict into an explicit evidence-weighing exercise for the AI. Okay, the big question. Did this structured, somewhat complex approach actually work in testing? What was the performance boost?
It seems to have paid off significantly. The results showed that astute RAG consistently outperformed other methods designed to enhance RAG robustness. This was across a range of datasets, general knowledge, specific domains, even long-tail questions. For instance, using the Claude model, astute RAG showed a relative improvement of nearly 7%, 6.85%, compared to the next best baseline method. That's a solid gain, suggesting that structured reasoning really does help.
Okay, consistent improvement is good. But what about the really tough cases? The worst case scenarios where RAG completely fails and just retrieves garbage.
That's where astute RAG really shone, according to the sources. They used a benchmark called RGB, which is specifically designed to test RAG systems when all the retrieved documents are negative, meaning they're irrelevant, misleading, or just don't contain the answer.
The ultimate stress test for RAG reliance.
Exactly. And in these scenarios, the performance difference between a standard naive RAG system and just using the LLM on its own, no RAG, was massive, often over 50 points difference. It showed how badly poor retrieval can cripple a good LLM.
So standard RAG makes a smart LLM dumb when fed bad info.
Pretty much. But astute RAG was reportedly the only robustness-enhanced RAG method they tested that managed to perform nearly as well as, or sometimes even better than, the LLM running in no RAG mode on these worst-case inputs.
Whoa, how does it know to basically ignore the ARIG results when they're all bad? What's the mechanism?
It goes back to that consolidation step. Step 2. Because the LLM is explicitly asked to cluster passages, check for consistency, and assess relevance against its internal knowledge. If all the external passages are inconsistent with each other and inconsistent with the high-confidence internal passage, the system effectively recognizes this. The confidence score for the external information cluster plummets. If it drops below a certain threshold, the framework essentially tells the LLM, okay, the retrieve stuff looks unreliable or irrelevant. Rely primarily on your vetted internal knowledge for the answer.
Ah, so it has a built-in bailout mechanism based on reasoned inconsistency detection. It learns to trust its own constitutional memory when the external world seems chaotic.
That's a good way to put it. It avoids being dragged down by the noise because it has this internal anchor and a process to evaluate the external signal's quality.
And specifically on resolving those direct conflicts, like the Einstein example where one side was right and one was wrong.
In those specific conflict instances identified in the data, astute RAG was able to choose the correct side of the conflict about 80% of the time.
80% resolution accuracy. That's a huge jump from the near 50-50 baseline problem.
It really suggests that this structured, source-aware reasoning is highly effective for improving factuality in the face of conflicting information. It's a very promising academic framework.
Okay, so astute RAG gives us a picture of a highly structured, almost judicial approach to RAG robustness in the lab. Now let's contrast that with how RAG works out in the wild, in a widely used commercial product. Part 3, Google's NotebookLM.
Right. NotebookLM is positioned differently. It's not just a general-purpose chatbot. It's marketed as a specialized AI tool, really a research and writing assistant. It runs on Google's powerful Gemini models, like Gemini 1.5 Pro, and uses their LearnLM framework. Its whole philosophy is built around being a closed system.
Meaning it only looks at the documents you give it.
Exactly. You upload your PDFs, your Google Docs, text files, web links, even audio and video, which it transcribes, and it promises to base its answers only on that specific set of sources.
The goal being to drastically reduce hallucinations and factual errors by keeping it leash to your provided material. Verifiability is key.
Precisely. And architecturally, it's built for scale. It can handle a good range of document types. The limits are pretty generous too per source, up to 500,000 words or 200 milwood. On the personal tier, you can load up to 50 sources, and paid tiers go higher.
How does it process all that diverse input?
It works by converting everything into a unified text format first. So audio becomes a transcript, video becomes a transcript, PDFs have their text extracted. Then this text is broken down into manageable chunks. And these chunks are then vectorized, turned into numerical representations using advanced embedding models, like Gemini embedding 001 mentioned in the sources. This allows for efficient semantic search later.
And for the retrieval step, finding the relevant chunks for a given query.
It uses a hybrid approach, which is generally considered best practice. It combines traditional keyword search, good for finding specific names, terms, or dates, with semantic vector search, which is better at finding conceptually related information even if the wording isn't identical.
That hybrid approach should theoretically help with some of the problems we discussed, like finding specific detail.
It should. And another major technical aspect is the context window of the underlying Gemini models. They boast up to a 1 million token context window.
Which translates to a lot of pages.
Yeah, potentially allowing the model to consider something like 1,500 pages of text simultaneously during the generation phase, which is massive compared to older models.
And a core feature that users seem to value is the citation system.
Absolutely. NotebookLM provides very clear inline citations that link directly back to the exact passage in your original source document where it found the information. For anyone doing serious research or writing, that traceability is crucial for trust and verification. You can click and see the original context instantly.
Okay, now let's talk about a really unique feature, especially relevant to our theme of new voices today, the audio overviews feature.
Yes, this is quite innovative. It goes beyond just summarizing your documents. NotebookLM can actually take your textual sources and transform them into an AI-generated audio discussion, almost like a mini podcast about your own material.
So instead of reading notes, you can listen to a conversation about them.
Exactly. Imagine feeding it a dense research paper and getting back a 5 or 10-minute audio dialogue where two voices discuss the key findings, methodology, and conclusions.
How does that work technically? It's not just reading text aloud, right?
No, it's more complex. First, the RA-grounded LLM, using your documents as its knowledge base, synthesizes a conversational script. It has to figure out how to turn the factual content into a natural-sounding dialogue between two speakers.
So it's actually writing a mini play based on the source material.
Kind of, yeah. Then, that generated script is fed into a sophisticated text-to-speech, or TTS engine. And this TTS engine is capable of producing very natural conversational-sounding speech. And the key here, linking to the new voices idea, is that the output features two distinct AI-generated voices. They have different vocal characteristics, making it sound like a genuine back-and-forth discussion.
That's fascinating. You upload text and you get back two AI personalities discussing it. Does the user have any control over this?
Yes, you can typically select the desired duration, like a shorter summary, a default length, or a longer, more detailed discussion. And the sources mention an even more advanced feature, an interactive mode. This apparently allows you to interrupt the audio playback, ask a clarifying question, or suggest a new direction for the discussion.
And the AI adapts the conversation on the fly.
That's what it implies. The LLM would have to dynamically replan the rest of the dialogue script based on your interruption. That moves it from just being generated audio to a truly interactive, grounded conversational agent.
That really showcases the potential when you combine powerful LLMs, robust RAG, and advanced TTS. Very cool. But, and there's always a but, we now move to part 4. Despite this impressive architecture, the closed system, the big context window, the cool features, users are running into some significant walls.
Yeah, and this is where we hit the context window paradox. We hear 1 million tokens, we see the marketing about analyzing huge amounts of text, and we assume the AI is omnisciently reading every single word of our uploaded documents all at once.
But that's not actually how it works in practice.
Not according to user reports. People found that even with relatively large single documents uploaded, NotebookLM sometimes seemed unable to access the whole thing. We saw specific examples where a user uploaded, say, a 146-page document, asked a question, and the citations or answers only referred to a weirdly specific chunk in the middle, like pages 97 to 149. The AI seemed blind to the beginning and end of its own source material.
Wait, how is that possible with a 1 million token window? Surely 146 pages fits within that easily.
It likely does fit within the LLM's potential context window. But the bottleneck isn't the LLM's reading capacity. It's the RAG retrieval step that happens before the LLM sees the data.
Okay, so the RAG system first searches through the chunked document.
Right. It chunks the 146 pages, vectorizes them, and when you ask a question, the RAG search algorithm retrieves only the chunks it deems most relevant to your query based on keywords or semantic similarity.
And it's only those selected chunks that get passed into the LLM's massive context window for final processing and answer generation.
Exactly. The LLM, despite its huge capacity, only ever sees the subset of information that the RAG retrieval system decides to show it. If the retrieval algorithm, for whatever reason, doesn't rank the chunks containing the introduction or the conclusion as relevant to your specific question, the LLM never knows they exist.
So the 1 million token window describes the size of the LLM's working memory, but RAG acts as a gatekeeper, potentially only filling a small portion of that memory with retrieved snippets.
Precisely. And if the query is broad, or if the key information is in a section the retrieval algorithm misses, you get these bizarre omissions and blind spots, even within a single document.
That completely changes how you have to think about interacting with it. It's not like talking to someone who has read the whole book. It's like talking to someone who has only been given selected index cards about the book.
That's a very good analogy. And this limitation becomes even more apparent when users try to ask questions about the document structure or try to get precise quantitative information from it.
Right, the failures on exact or metadata questions. RJ is built for semantics, for meaning,
Right.
not necessarily for counting or structure.
Exactly. Users reported simple things failing. Asking, what is the first sentence of this document, might fail because the chunk containing the first sentence wasn't deemed relevant by the retrieval algorithm for that query. Same for the last sentence.
Because relevance is usually about content similarity, not positional information.
Right. And it gets worse with anything involving counting or precise data extraction. LLMs, in general, are notoriously bad at math and precise counting, and the RAG layer doesn't magically fix that. In fact, it can make it worse.
You mean like asking it to count words?
Yeah. There was an example where a user uploaded a very short story, only 970 words, and asked NotebookLM to count how many times the word fish appeared. It got the number wrong. Sometimes it would even hallucinate counts for words that weren't even in the story, because it's not actually scanning and counting like a database. It's using the retrieved chunks and its language model capabilities to estimate or generate an answer, which is unreliable for precise counts.
That distinction is critical. It's a language processor, not a data analysis tool in the numerical sense.
Yeah.
But the most alarming example was the word count discrepancy on a large file.
Oh yeah, that one really highlights the danger of the Argo bottleneck. A user uploaded a large book. They asked NotebookLM about the word count, presumably to get a sense of the scope. NotebookLM, based only on the limited excerpts that the Argyle system retrieved and passed into its context window, reported the book had about 28,000 words.
Okay. And the actual count?
The full uploaded file actually contained nearly 81,000 words.
Whoa! That's not even close.
Yeah.
It missed more than 2/3 of the document's content in its estimation.
Exactly. And imagine relying on that 28,000 number for any kind of analysis or comparison. It's dangerously misleading, stemming directly from the Argyle system's failure to provide the full picture to the LLM.
So RI can be a poor tool if you need comprehensive, quantitative, or structurally precise information, even from your own documents.
It seems so, and this forces users into developing these manual workarounds, which kind of undermines the whole AI assistant idea.
What kind of workaround?
People are reporting they now have to manually pre-chunk their long documents, break a book into individual chapters, or a long report into sections before uploading them to NotebookLM.
Why? To ensure each smaller piece is fully processed.
Essentially, yeah. To try and force the RAG system to see all the content by dealing with smaller, more manageable units where retrieval is less likely to miss entire sections. They're also learning to ask very specific questions targeted at known sections rather than broad queries.
So users are having to become amateur data engineers, essentially pre-processing their own data just to compensate for the RAG system's hidden limitations.
That's exactly what it sounds like. And this leads to what the sources called a trust paradox. NotebookLM is built on the promise of verifiability with its citations. But because of these hidden retrieval limits, users find they still have to double-check everything. They have to constantly wonder, did it actually analyze the whole document for that summary or just a few key chunks?
And that quote from a user really summed up the anxiety. What if the missed instance is the one thing that is really, really important? The outlier that will turn everything on its head and oops, it missed it.
That fear that the AI's convenient summary might have conveniently omitted the most crucial piece of contradictory evidence because the RAG retrieval missed it? That's a serious challenge to trust, even with inline citations.
Okay, let's try and synthesize this. We've seen two approaches to making RAG more robust. Astute RAG from the academic side, and NotebookLM representing a sophisticated commercial implementation.
The core difference that stands out, I think, is the mechanism for handling conflict and uncertainty. Astute RAG uses that explicit three-step process with source awareness. It forces the LLM to reason about internal versus external evidence, consistency, relevance. It's very structured.
Whereas NotebookLM seems to rely more on the power of its underlying model, Gemini, a large context window, and good retrieval, hybrid search, but lacks that explicit, transparent conflict resolution layer. Its main robustness strategy is the closed system constraint.
Right. And NotebookLM's architecture, while great for scale and usability, seems to run into trouble when the structure or completeness of the information within a single source is critical due to those RAG retrieval limitations we discussed. It favors broad semantic understanding over exhaustive structural detail.
So the trade-off for NotebookLM scale and ease of use might be a reduction in guaranteed analytical depth on very large single sources compared to the theoretical promise of something like astute RAGs methodology.
That seems fair. And the big takeaway really is that making RAG truly robust is still a major hurdle. That 50-50 split in conflict correctness tells us you need both internal and external knowledge, and you need a smart way to mediate between them.
It's not just about finding relevant stuff, it's about intelligently fusing potentially contradictory information.
Exactly. And this points towards maybe not looking for a single AI tool to rule them all, but using specialized tools in a workflow.
Right, leveraging the strengths of different RAG approaches. How might that look?
Well, based on the tools and issues discussed, you could imagine a workflow like this. For initial discovery, finding relevant information out on the web, casting a wide net, you might use something like Perplexity, which is known for its strong web search and synthesis capabilities. Gather your raw materials.
Okay, so Perplexity for broad searching. Then what?
Then, for deep analysis of the documents you've gathered and curated, you'd bring them into NotebookLM. You'd leverage its closed system focus for grounded analysis, its summarization, its Q&A features, knowing its strengths lie in semantic understanding of the content you provide. But you'd be mindful of its limitations, maybe pre-chunking large docs.
And using its citation feature heavily for verification. And then for actually communicating or presenting the findings.
That's where the production stage comes in. You could take that cool audio overview script that NotebookLM generates, the one with the two AI voices discussing your research.
The new voices.
Right, and you could feed that script into a dedicated audio production tool, maybe something like Wondercraft, which excels at adding professional, polished, high-quality voice synthesis options, music, sound effects, easy editing. You enhance NotebookLM's raw output into a finished product.
So a chain. Discover Perplexity, analyze NotebookLM, produce Wondercraft. Each tool playing to its RG-related strengths.
Precisely. It acknowledges that different stages of the knowledge lifecycle might need different RG optimizations. So we've seen today that RGA, while crucial, isn't a silver bullet. Its reliability hinges on managing internal conflicts and, perhaps even more fundamentally, ensuring the retrieval step is not just relevant, but also complete for the task at hand. And that leaves us with a final thought, maybe a bit provocative, for you, the user. If the reliability of an AI's analysis depends on how well its ARGIS system retrieves information, and that retrieval can be significantly hampered by things like document size or structure, does this mean that as AI gets more powerful, we need to become better data curators? Will we all need to learn the basics of data engineering, like how to optimally chunk our documents, just to ensure the AI we're relying on actually sees the whole picture it needs to give us a trustworthy answer?